In this section, we want to talk about the polynomial function of high degree. So we have learned the function, the linear function, which is ax plus b, right? And we have the quadratic function, which is ax squared plus bx plus c. So these are the special polynomials. The first one has the polynomial with degree 1, right? The second one is the polynomial with degree 2. So we know for degree 1 polynomial, which is actually a linear function, this represents a straight line, and the degree 2 polynomial function, which is actually a quadratic function, which is a parabola for the graph. So here I want to quick review the definition for a polynomial function, the general polynomial function. The polynomial function can have this kind of following form: f of x equals a sub n times x to the n plus a n minus 1 times x to the n minus 1 plus continue plus a1 times x to the 1, so just x, just plus a0. Okay, so here this is called a polynomial with degree n, which is the highest power, right? Which is the highest power of the x terms. So here, a1, a0, a1, a2 to an, these are called coefficients. And an, which is the coefficient for the highest power term, we give a special name which is called the leading coefficient. Leading coefficient. And a0, which has no x term, we give a name. This is called the constant coefficient. Okay, so now let's look at some remarks for this definition. The first one, if you have a constant function, this represents a horizontal line, right? Which is actually a polynomial with degree 0, right? X to the 0, which is equal to 1. And we have, this is at the beginning I said, this is a linear function. This is a special case for the polynomial, a special polynomial with degree 1. And we have the f of x equals the quadratic function, ax squared plus bx plus c. This is the special polynomial with degree 2. So we have studied these functions already, and we know the graph and we know the properties, right? So now in this part, we are interested in this part, in this section. We're interested in the n, which is greater than or equal to 3. We want to develop some properties for the general polynomials, and we want to sketch the graph for the general polynomial. Okay, and 3, the polynomial has a very good properties. The reason is the graph of the polynomial is continuous. and smooth. Continuous and smooth. Okay, what does this mean? This means there is no breaks in the on the line, on the curve, no holes, no gaps, and no sharp turns. Okay, so the graph will look like this one, right? Just like this kind of graph. Okay. No holes, no breaks, no gaps, no sharp turns. Everything is continuous and smooth. So now let's look at some examples. So this is a function which is x to the negative 5 plus 2x. So let's look at if this one is a polynomial. We say, okay, this is not a polynomial because the polynomial from the definition, the smallest power is 0, right? There is no negative powers for the x terms. But here we have x to the negative 5, so this is not a polynomial. If f of x equals x plus square root 5 over 2 times x to the 5th, yes, this is a polynomial, right? The degree is with degree what? Which is the highest power, 5, so degree 5. Okay, so now let's look at this kind of function, which is f of x is equal to x to the n. This is called the power function. Power function. And we know that if n equals 1, which is a straight line, right? This is f of x equals x, which is this line. This is f of x equals x, or y equals x. If n equals even number 2, right? If n equals 2, if n equals 2, n is even. 2, 4, and 6, right? This kind of things. If n equals 2, it would be this parabola. Okay. And if n equals, this is y f of x equals x squared. If n equals 4, the graph will look like this one. Okay, the graph will look like this one. This is f of x equals x to the 4th. So from the graph, you can see the greater n is the flatter near the origin. So near the origin, it's much flatter, right? And the same for the odd number. If n equals n is odd. Okay, let's look at n equals 3. n equals 3 is this one. This is f of x equals x cubed. Then if n equals 5, it would be this one. This is f of x equals x to the 5th. Okay, so you can see this one is the greater n, the flatter near the origin. The greater in the flatter of the graph near the origin. Right? So you can see near the origin much flatter, right? So now we have this kind of power function. So we have some basic ideas of the graph for the power function, right? So if the n is a even number, it always be a parabola, but the greater n, the flatter near the origin, okay? In other words, if n is increasing and is even, then the curve becomes flatter near the origin. So now let's look at, we want to use this kind of power function, the graph of the power function. Let's try to sketch the graph for this one. X plus 1 to the fourth. Okay, so you can see that the parent function for this one, the original function, the parent function for this f is what? Is kind of g of x. We use another letter, g, x to the fourth, right? So we know x to the fourth would be this one, right? This is gx. So what is f of x, f which is x1, x plus 1 to the fourth, so which is actually g of x plus 1, right? Do you remember, if we add 1 on x, that means you need to move to the left by 1 unit, right? So let's use another color. So we use 1, right? So the graph will look like this one. Okay, so this is the f of x equals x plus 1 to the fourth. Another example, if we want to know the graph for the h of x, which is 7 minus x to the fourth. Okay, so now let's start from the parent function. The parent function would be y equals another letter f of x, that doesn't matter, y equals x to the fourth, right? X to the fourth is what? Is this one. We know that it's just much flatter near the origin, and that's fine. We just sketch the graph, okay? Then we have what we have. We have the next one is we multiply by -1 on the whole function, So that means we will reflect the graph about x-axis, which would be this one. Then the last step is we will have y equals 7 minus x to the fourth. So 7 minus, you can write this one as negative x to the fourth. This function, we plus 7. So we plus 7 on the whole function. So that means we will move up 7 units, right? Move up 7 units. So here is 7, for example. So we use another color. So it will look like this one, right? We will move up 7 units.